Hello everybody and welcome back to Operation Logistics, where I just completely forgot to hit the start button and was going for about 2 minutes. So here's what we did. Up here we added public bool randomized seed equals true, so we're defaulting that to true. And then down here in the generate map I added an if statement, if randomized seed, then we random.init state, random.range, int.minValue, int.maxValue. So anywhere in the range of an integer. If we're not randomizing the seed, then we init state based on the seed that we give. And that's all I did. And it didn't quite work yet, but we'll see if this works now. It won't work. And I'm trying to figure out exactly why it won't work. So our seed is still 77, and actually it will work, because we're not actually changing the seed. I was checking over here, and I was like, why isn't it changing? Because we're not changing it. We don't need to change it. This is a different map every time. Fantastic. Okay, so the next thing that I would like to do, now that we've gone over what I accidentally implemented off camera, the next thing I would like to do is change the fact that, actually, now that I'm thinking about it, there are a couple of things that I want to do. I want to duplicate border material. Right? Maybe. No, it's fine. It's fine. I'll leave it the way it is. We can always adjust this later. So the first thing that I want to do is back to where I was a moment ago, and that is the simple fact that you click on a water tile, it zooms to the tile, and gives you a bunch of land there. That's not really what I'm looking for right now. Another thing we might want to consider is, and this is maybe something that you don't want to do right now, depending on how much computer power you have. I want to go into quality here and bump up the multi-sampling to 8x. Just for right now. I just want to be able to see my borders a little bit better, hopefully. Hopefully with a little bit better anti-aliasing. Or, you know, have it be worse. That works too. Either way, I'm not deeply concerned about that, shall we say. Okay, so the question now becomes, how do we have this not happen? Well, there's a simple way to do it. And that is, what if we just don't zoom to the hex if it's a water hex? So in the onMouseOver, we could simply say if classification equals hex classification.water, return. We need a double equals, not a single equals. It's an evaluation. There we go. So now if it's a water type hex, it just won't zoom to it at all. Problem solved, right? Well, yes and no. But let's see here. Yep, it will not zoom to water hexes anymore. Fantastic. But it will still zoom to a land hex. Now we do have a bit of a problem with borders in our land hexes. And we also have a bit of a problem in that it won't right-click on water hexes, which I do still want it to zoom out if we right-click on a water hex. So instead, we can do something along the lines of this. Get rid of the else here. Take this, put it up top, and say, if we're trying to zoom out, go ahead and zoom it out. That's fine, I don't care. However, if we have a classification of water, return, else, and the else is kind of irrelevant, but if we don't have a classification of water, then feel free to try to zoom to it. That'll be fine. So now we will not be able to zoom to water, but we'll be able to zoom out from water. Theoretically. Yep, can't zoom to water, we can zoom to land. If we zoom to land next to water and click on the water, we can zoom out with a right click. Fantastic. That is pretty nice. Okay, so with that taken care of, the next thing that I'd like to think about doing is setting up some sort of a slightly awkward system And let me just pull open, I've got a script pre-written for this that we can implement, but I'll need to open it up here. Where did I put that? It was for my grand strategy that I'm working on eventually. Okay, I believe it was in landtile.cs. Let's see here. Yeah, that's what I'm looking for. Okay, so in base hex here, let's go ahead and create ourselves a new function. And it's a good thing that we have our mesh renderer, except we don't need our mesh renderer for this. And I'm going to go ahead and make this be a private variable, private mesh filter mf. I mean, that seems slightly vulgar, but we'll go with it. Mesh filter mf. And then down here, we will say this is a public function, public void set overlay color. And for performance reasons, we're not going to be using color. We're going to be using color 32, which the difference between color and color 32 is just the format. Color 32, as you can see here, is a representation of RGBA colors in 32-bit format, whereas color is just a representation of RGBA colors. So we do want it in 32-bit format because Unity works with that internally for performance reasons. We don't want to be casting it all over the place. So let's just have that and go to new overlay color. There we go. And now we're not going to return anything, but this is going to be a relatively simple function. Color 32, we need an array of it, colors. So let's create ourselves an array of color 32s, and then we can say if our mesh filter dot mesh dot colors32 dot length equals 0. So if there is not currently any mesh colors, any vertex colors here, then we can say colors equals new color 32, and we'll need an array here, and the length should be mf.mesh.vertexCount. So the number of vertices that we have in the mesh is the number of vertexes, or vertices, that we'll need here. I got it right the first time and wrong the second time. It's a little weird. If we already have an array here, then let's just co-opt that array, steal that, colors, whoa, volot D. Helps if my hands are in the right place on the keyboard. Colors equals mf.mesh.colors32. So we just co-opt their existing array. So int I equals 0, while I is less than colors.length. We're just going to loop through this and set all of the colors to be the same color. So this isn't going to have support for coloring different parts of the mesh different colors, which is going to be potentially a little awkward, but we've got our tint color. We'll have to see how it works. We may have to do this a little bit differently, but we'll find out. So we'll just simply say colors I equals new overlay color. Why did I do this in a while loop before anyway? I hate while loops. I've been burned by them so many times because of infinite loops. I'm going to change this to a for loop. For int I equals 0, I is less than colors.length, I++. We don't need this declaration anymore. And that's all we need here. So equals new overlay color. And then down here, all we got to do is assign it back. So mf.mesh.colors32 equals colors. So we can now assign an overlay color to the hex, which is going to be super, super convenient. So let's go ahead and change our hex material here to, instead of being this green color, which we may want to actually let's keep that around for the time being. I'll just keep that on my other monitor so that I can actually see what's going on there. And it went away. Never mind. Okay, so in the hex manager, we need to be determining at some point our Voronoi for urban versus rural. So let's go ahead and create ourselves a function down here. And I think this is the correct one. Yes, indeed it is. So let's create ourselves a public void create urban, we'll call it. Do we need any arguments here? Maybe not. I don't think we do. So map settings here. Let's go ahead and change this to header height settings. And then down here, let's go for header city settings. And let's say public int number of cities equals, I don't know, let's default to 4 for right now. We can always adjust this later since we're not hard coding. So in our create urban, we're going to need to say, okay, so we have 4 city seeds. That's great. So while number of cities, and actually I'm going to create a new one here. So int city seeds equals number of cities. And then down here, while number of cities, not number of cities, while city seeds is not equal to 0, right? That's how I did it before. I went for greater than 0. That's still fine. Okay, so we now need to iterate through and get ourselves some city seeds. So the way we're going to do that is basically the same as we did it up here. So int x and y equals random.range. And then we need to check to make sure of a couple of things. One, we need to make sure that we are not in water. So if map x y dot classification is not equal to hex classification dot water, then we go on. Actually, if it equals it, maybe we just continue. Continue. That'll continue the while loop, right? Yeah. Excellent. So if it's water, we just try again. We need to keep going. And then if it isn't water, if it's rural, because we know it'll be rural at this point if it isn't water, then we can go ahead and do a couple of things. One, we'll need a list here. So not public. We will need a list of base hex city seeds. And actually, I'm just going to call this cities equals new list base hex. Okay. And then down here, I will say city seeds minus minus. We will go ahead and add map xy. So cities dot add map, whoa. There we go. Map x y. Okay, so we have our cities spawning, kind of, but we aren't actually showing anything here. We can go ahead and say map xy dot classification equals x classification dot urban. There we go. We don't need to evaluate it. What am I talking about? We want to assign that. There we go. And the other thing that I would like to do is at this point, I would like to go ahead and change the color of the urban hexes so that we can actually see them, so they stand out a bit. So let's go ahead and say map xy dot set overlay color. And this color is going to be, well, for right now, this color is going to be color dot, we'll just go with color dot gray. There we go. So we should theoretically be able to see our cities now. There'll only be the one city seed tile, but that's okay. Uh-huh. Uh-huh. I'm afraid I don't see them. Let's go ahead and set hex material to have a base color of white. So that way, with any luck, it will stand out. You know what the problem is? I know what the problem is. The problem Well, first off, I'm going to make that back to green. The problem here is that we're not calling create urban. So after create height, create urban. There we go. Now we're not iterating through the rest of the list just yet, but we should at least have seeds for cities now. Maybe. Object reference not set to instance of object. Line 80. Okay, well there's the problem. Right, because we're not actually assigning in the base hex. We're not actually getting the mesh filter. So we just need to do mf equals get component mesh filter. There. That should help. It helps if I tell it what a mesh filter is. Now we shouldn't have any errors. And now I can actually see city seeds. Fantastic. So we can see that there's two city seeds basically right next to each other. That's going to merge into one big ol' city. But that's fine. Now the question is, how do we want to go about doing this? Well, I think the first thing that we should do is go into our enum here and say default. Let's have a default hex classification. And then in the hex manager, let's go ahead and have our rural go to default now. Because I just kind of don't want... do we need to do that twice? Classification water, else classification default. Now, if we were to remove this, it would default to default. But that's okay. So, we now have this going on. And the question then becomes, how many rurals do we want to do? Do we want to do the same number of rurals? Maybe. Maybe we do. I do want to go ahead and do new color 32 here. And we are going to... Hang on. Color.gray is equal to what? 0.5, 0.5, 0.5? Okay. 0.5f. Oh yeah, these are bytes, aren't they? Is there a float variant of color 32? Apparently not. It's fine. We'll just use color and have Unity cast it. Go ahead. Go ahead and do that. That's fine. So, the question now becomes, do we want to do this a little bit differently? No, I think not. I think we just have the same number right here of hang on. I lost my train of thought. Let's redo city seeds here. And let's just iterate through again, and instead of setting it to urban, we will set it to rural. And we will set it to color dot green. This is going to be a really bright green, so let's multiply it by half. Okay. Hex classification dot defa, apparently. Default. Okay. And then let's go ahead and go into our materials and change hex material at this point to be white. And let's change border material actually to be just like a light gray. Maybe full on half. So 128, 128, 128. There we go. So now hopefully the border material will be tinted by the other colors, so that it matches a bit more the type of terrain it's on. That would be nice. Okay, so we're now going to have ourselves an interesting scenario where that's happening. Not a huge fan of that. A lot of that's because the water really needs to be colored manually. So we're currently at 120, 200, we'll call it. That's fine. Let's hop into here and color our water. So we're setting the water material, and that's fine. It still needs to be set that way. But whenever we set the water material, let's go ahead and do a set overlay color call at the same time. So right here, and I will have it be a new color. And the color will be 0, 0.5, and 0.8, something like that. Because it's 0 through 1. Actually, I can find out the exact amounts. Let's pull up the calculator here. And let's see here. 118 divided by 255, 0.46. We'll round it. 0.46. And then 200 divided by 255 is 0.78. That was pretty close, actually. Okay. So we'll set that overlay color, and this should be IJ, not XJ. That's even worse. Okay, we'll set it right up here. Fantastic. So there's our water being set, and I'm going to go ahead and color the water, the base color of water, pure white. And I think I changed something horribly there. Maybe not. We'll make that be pure white. And now it should color the water based on mesh colors rather than on the material color. But otherwise, it should be basically the same, and you can see that the coloration of the border is quite nice now, actually. And then up here, you can see that the borders are similarly tinted to reflect the type of hex that it's on. Nice. Okay. So, we can now go ahead and set up some more Voronoi down here, because we have our rural and our urban seeds. So, we can then say something along the lines of this, iterate through the map. I mean, I'm not going to be having most of this here, but we can iterate through the map at this point and do that. That was a lot of work just to copy and paste that. That might not have been the most efficient way to do it. But then we can do, well, we're actually going to still be utilizing a fair amount of this. So we can say something along the lines of this. Copy that in here. So if we don't need to check the height at this point, but we do need to say if the classification is water, we don't need to do anything. All of the water is already set up at this point. So once the water is set up, then all we need to do is iterate through the non-water hexes. So let's go ahead and do that. And nearest, I'm going to use cities rather than Voronoi seeds. But otherwise, it'll be basically the same. So we now know what our nearest city is, correct? K and then new pose, yeah. Okay, so we now know what our nearest city is. Or rather, what our nearest Voronoi is. It's not necessarily cities at this point, but you get the idea. So then we need to determine if nearest.classification is hexclassification.rural. Then we need to do something else if nearest.classification equals hexclassification.urban. Then we need to do something. And what do we need to do? Well, if we do rural, just this. Just set the hex classification, and then it needs to be IJ. Oh boy. This is what I get for mixing nomenclature all the time. Just this, and then if we are urban, then gray and urban. Okay, so now it should theoretically set up our maps in a bit more interesting of a fashion. Theoretically. And does it? Yeah, actually, it does. So it looks like we've got kind of a mega city going on over here, separated by a couple of straits. And then we've got some more rural areas off over this way. Not bad. Now you can see that these tiles are all currently not colored when we zoom in to a particular tile. But that's fine. We can always do that later. Excellent. I do believe that that is fantastic progress, and since we've got the harsh border between our hexes here, we can actually not even see the discontinuity, I guess is the term I'm looking for, between our hexes here. It looks pretty good, actually. I wonder if there is actually a discontinuity there. I don't know. At any rate, I do want to run a quick check here before we actually end this episode. This will only take a moment, and see what actually happens as we approach white here. Okay. Interesting to note. That's fine. I don't actually want to change that. I just wanted to know what it looked like. Excellent. Okay, so with that in mind, I do believe it's time to put a cut in here, and next episode, what will we be doing? Well, we might be working on subtiles some, or maybe working on some of the subclassifications of urban versus rural. But overall, I'm incredibly pleased with our progress so far. I feel like this is going pretty great. So I'm going to go ahead and put a cut in here, and next episode, we will continue work on this project. See you all then.